All right. Can you see it?
Yes.
Yes. So hello, my name is Alberto Sannino, and I'm going to give you a very brief overview of FastPay. So this is a 5-minute talk, so I'm not going to explain you how it works. I'm just going to say what it is, and hopefully if you get interested, you can talk to me later. So FastPay is a typical example of research work we do at Novi Research. So I hope it gives you a good overview of the kind of work we do. So first of all, this is joint work with Matthew and George. Both are researchers and engineers at Facebook Novi with me. So what is FastPay? So FastPay is a distributed system, a BFT system. It's a payment infrastructure, and it is extremely low latency. That is particular point with respect to all other payment systems that are distributed. So FastPay works in the general BFT settings, so it's composed of a set of nodes, a set of authorities, 3f plus 1 authorities of standard Byzantine assumption, out of which at most f can be malicious. And the goal that we want here, the design of FastPay, is to make distributed payment system practical for retail payments at physical points of sale. This means that we would like to have distributed payments in such a way that you can go to a coffee shop, buy coffee, pay with this kind of system, and have the payments finished and settled straight away. And this, of course, requires extremely low latency, arguably much lower latency than what traditional blockchains and current state-of-the-art blockchains give you. So what is the current industry standard in that respect? So first of all, we want low latency, we want BFT resilience, of course, and we want fast finality and high capacity. Fast finality means that we want to have a system in such a way that once we make the payment, it's finalized and settled very quickly, and the payment cannot be reverted. And high capacity means that we want a lot of users to be able to use the system at the same time. So the current industry system does not seem to do a good job at that at the moment. First of all, most of them are extremely centralized. This means that they often work with very old master-slave implementations, and it incurs enormous operational costs. For instance, they need to make sure that the system is always up and running. What happens when this master goes down and we need to switch to the slave? What happens if the right people should get access to the system, but not the malicious people, and so on and so forth. And secondly, they have very slow finality. People may think that your credit card payments are fast, but actually they're not really payments. They're just promises of payments. Most of the time when you pay with your credit card, the provider and the banks will just emit a promise of payments, and banks will settle the net payment usually at the end of the day. And this again creates huge credit risks because the merchants banking to make sure that the money will be there at the end of the day. So FastPay solves those problems, but FastPay is not a blockchain. Traditionally, blockchain runs a primitive called Byzantine consensus, while FastPay is run on a weaker primitive, which is called Byzantine consistent broadcast. This means that FastPay cannot do all the things that a blockchain does, but what it do is payments, and it can do them with much lower latency than what Byzantine consensus can give you. And so that's it. If you're interested, come talk to me. You have here a link to the full paper, and that has the full system and how it works, and a link to the code because we implemented it, tested it extensively, and we show the latency and the throughput that we get for a different number of nodes and different test beds. So I'm happy to take any questions if there are any. I think I'm exactly 1 minute left for that.